Okay, in this class I'm going to look at two measures of dispersion we haven't looked at yet. One is called the variance and the second one is called the standard deviation. Standard deviation is actually just the square root of the variance. So we look at the variance first. And the variance is just the average of the square differences from the mean. That's the idea. It's the average of the square differences from the mean. So we find out the mean first of all. We'll find out how far each data point is away from the mean. We'll square that difference, that distance from the mean, and then we take the average of all those distances. So I want to find the mean and hence the variance of each of these data sets. So to find the mean, again, this is something we looked at before. We add up all the data points and divide by the number of data points. 2 plus 4 plus 6 plus 8, that adds to 20. Divide by 4, the number of data points. The mean here is 5. So the mean, I'm going to call it x bar, the mean is equal to 5. In the second data set, 4 and 5 is 9, 9 and 5, 14, 14 and 6 is 20, 20 divided by 4. Again, we're getting a mean of 5 units here. And then finally, we're going to add up all these data points. Negative 10 and 20, well, that's 10, 17, 22, 25, but I'm dividing by 5 data points here. Note, again, we have a mean of 5. We're going to find the variance of each of these data sets, okay, using my definition. We'll talk again in another class about using your calculator to find all these things. Your calculator will do all this stuff. You can input the data set and then just choose an option to select the standard deviation and the variance. But in this case, I'm just going to look at the variance. Okay, so note each of these data sets has a mean of 5. We're looking for, which one has values that are most spread out away from the mean. And you might just look at those before we calculate the variance. So without doing any calculations, you could probably make a guess at which one looks the most spread out away from the mean and which one looks the least spread out away from the mean. And that's what the variance is going to tell us about. So what we do is to find the variance, we find the average of the square differences from the mean. So we're going to take each data point and look at how far the square distance is away from the mean and then take the average. So if I go through this first data set, if I look at 2, well, 2 is 3 units away from the mean. So if I look at the square of that difference, well, that's 3 squared. I'm going to look at all the square differences. So the distance 2 is from the mean is 3 units, so I'm going to square 3. 4 is only 1 unit away from the mean of 5, so I'm going to square that 1. 6 is also just 1 unit away from the mean 5 here. And then 8 is 3 units away from the mean, so I'm going to square. So I'm squaring all the distances away from the mean, and then take an average of all those square difference. I take an average by dividing by the amount of square differences. There are 1, 2, 3, 4 square differences here, so I'm dividing by 4. Okay. Squaring 9 plus 1, 10 plus 1, 11 plus another 9, well, that's 20 over 4, which is 5. So in that first data set, the variance is 5. In the second data set, again, we're going to take the square distances from the mean. 4, the distance of 4 from 5, well, that's 1 unit, so the square difference is 1 squared. 5 is 0 units away from the mean here. It is equal to the mean, so the square of that difference is 0 squared. 5 again, that's another 0 squared. And then finally 6 is 1 unit from the mean, so we're going to square that distance. That's 1 unit away from the mean, so we square 1. Again, there are 4 square differences here, so to take their average, we divide by 4. 1 squared plus 1 squared, well, that's 2. 2 over 4 is equal to 1/2. So the variance of the first one is 5 units. The variance of the second set is 1/2. Okay, 2/4, so 1/2. Finally, this last one, again looking at the differences from the mean, we're going to have 5 separate square differences. The first square difference will be the distance from negative 10 to 5, which is 15. Square it. And then the next one, the distance from 3 to 5, well, that's only 2 units, and we're going to square that difference from the mean. 5 is 0 units from the mean, so we're going to square that 0. 7 is 2 units from the mean squared. 20 again, 15 units from the mean of 5, square the 15. In this case, there are 5 squared differences, 5 squared distances. We're going to divide by 5. Okay, so we have 15 squared, 225, another 15 squared, that's 450, and then we have 4 and 4, 8. So I think it's working out to be 458 over 5. So 458 over 5, well, 5 into 45, 9. 5 into 8 goes once, remainder 3. 3/5 is 0.6. So it's 91.6. Okay? So these are the variances of the data set. And the symbol for variance we use is this. It's sigma squared. That's the symbol for variance. So sigma squared here is 5. In the second one, sigma squared is 1/2. In the third one, sigma squared is 91.6. Okay, so they're my variances here in this case. To find the mean, you add up all the data points, divide by the number of data points. To find the variance, you take the average of the squared distances from the mean. And what that's telling me is that this last data set is the most spread out away from the mean. The middle data set is the least spread out away from the mean. Okay, so 91.6 is the most spread out away from the mean. Half telling me that second data set is the least spread out away from the mean. Okay. The second measure of dispersion I want to talk about in this class is called the standard deviation. And standard deviation is simply described as the square root of the variance. So if the variance is 9, the standard deviation would be the square root of that, which would be 3. If the variance is 16, the standard deviation would be the square root of that, which would be 4. If the variance is 2, the standard deviation will be the square root of that, root 2. If the variance is 8, the standard deviation will be the square root of 8, which is 2 root 2. If the variance is 45, the standard deviation will be the square root of that 45, which would be 3 root 5. Okay? And generally when we deal with standard deviations, we don't leave it in third form. You'll usually see those written, as some kind of approximated decimals. And we'll talk more about why that is at a later date. Okay? So the notation for variance is sigma squared. The notation for standard deviation is sigma. And this is a very important quantity of dispersion. In fact, probably I would say our most important quantity for measuring dispersion away from the mean. Okay, so standard deviation is the square root of the variance. Define the variance. You add up all the, you find the distance each data point is away from the mean. You square that distance. You add up all those squares of distances and divide by the amount of things you added together. Variance is standard deviation. Okay.